This video is going to show you how to go from Ka to Kb, and then maybe I ought to do one where we go from Kb to Ka. So to do this, you need to remember the relationship between Ka and Kb, and that is that Kw equals Ka times Kb. Okay, so the first thing we're going to do is we're going to write the equation for the dissociation of the nitrous acid ion in water. So remember adic-itis. So this ends in us. So that tells me that this is the nitrite ion because these two are associated with each other. So nitrite is NO2 with a -1 charge. So the nitrous acid is HNO2. We can write it with water or without because it's an acid. Acids are proton donors, so we'll get nitrite and hydronium. Okay, if I'm identifying conjugate acids and bases, nitrous acid is my acid and its conjugate is the nitrite ion. So this relationship up here, Kw equals Ka times Kb, allows me to use the Ka for nitrous acid to find the Kb for the nitrite ion. So what I'm going to do is I'm going to take, I want to find Kb, so I'm going to do Kw divided by Ka, and the Ka is going to be for nitrous acid. So Kw is 1 times 10 to the negative 14th. The Ka for nitrous acid, I have to look up, and it is 4.0 times 10 to the negative 4th. So I'm going to do that math, and I get 2 sig figs, 2.5 times 10 to the negative 11th, and so that's the Kb for the nitrite ion. Okay, let's try another one. Here we want to write the equation for the dissociation of lactic acid in water. And lactic acid is that beautiful stuff that builds up in our muscles as we exercise anaerobically. So it is HC3H5O3. This one I'm going to write without water because I want you to get used to seeing it both ways. Acids are proton donors, and then we are left with the lactate ion. So if I do what I did in the example above, lactic acid is my acid, that means the lactate ion is my conjugate base. So I'm looking for the Kb of this conjugate base. I will use this relationship up at the top. So Kb is going to be equal to Kw divided by Ka. Kw is 1 times 10 to the negative 14th. Ka for lactic acid, I have to look up, and it is 1.38 times 10 to the negative 4th. Okay, when we solve, we get, I'm going to do, since this one had 3 sig figs, I'm going to go with 3 sig figs, 7.25 times 10 to the negative 11th. Now, just because we haven't talked about this in a little bit, if I wanted to compare strengths of the nitrite ion, this is its Kb, with the strength of the lactate ion, this is its Kb. I look at the size of the Kb's. They're both times 10 to the negative 11th, but 7.25 is larger than 2.5, so the lactate ion is a stronger base than the nitrite ion. Okay, I want to do one more example where we look at going from Kb to Ka. Okay, so we're doing the opposite here. Hang on, sorry, just a second. I need a pen. Oh, let's do green. Okay, so we're going to write the dissociation reaction for aniline, which is a weak base. And the reason I know that from the way this is worded is it wants to know the Ka of the conjugate acid of aniline. So that tells me that this has to be a base. So C6, H5, NH2, because it's a base, I want to include water. Equilibrium arrow. Bases are proton acceptors. The base is going to accept the proton from water. Carbons and hydrogens have to stay together, so that part is not going to change. So this hydrogen is going to get added on right here. So I'm going to have NH3. I added a proton to something neutral, so it's going to be H+, and then we get hydroxide. If I've lost my floating tools, I apologize. I don't know where they are, so we're not going to have any fun colors. Okay, so if I check these two things out, this is our proton acceptor, so that's our base, making this scary thing our conjugate acid. So in order to determine the Ka of this conjugate acid, I want to use Kw equals Ka times Kb. So I'm going to rearrange that. So I am solving for Ka. That will equal Kw divided by Kb. Kw is 1 times 10 to the negative 14th. And then Kb for aniline, I'm going to have to look up in the back of the book. And that is 3.8 times 10 to the negative 10th. So when I do the math for that, I'm going to have 1 times 10 to the negative 14th divided by 3.8 times 10 to the negative 10th. I am going to do two significant figures, so I get 2.6 times 10 to the negative 5th. And that is the Ka for aniline.